Lesson 3 to everyone. Today we're going to discuss part 2 of module 6 of the subject CE 3151. So in this lecture, we're going to discuss one of the methods for curve fitting, which is method group averages. The method for group averages is a numerical method which simply uses the average of two groups of coordinates. It shows a bigger discrepancy between the approximate and true values of points. So given our exact values and our approximate value or a line defining our approximate values, we take x sub k, y sub k for our coordinates, wherein k is equal now to points 1, 2, 3 until n. And since we are defining the relationship of our points or the coordinates x, y of the points in terms of a straight line, we now use function of x is equal to ax plus b. So take note, for the first point, we denote this as x1, y1. Second point is y2 and x2, and so on until we arrive at the last point, which is defined by xn, yn. And since f of x is what we call our y, which is dependent or is an approximation based on the value of x, so we take now the point intersecting points x1, x2 until xn with our approximation or approximated line as the function of x sub 1. Same, the point that intersects our line at x2 is our function of x sub 2 until the point intersecting xn is f of x sub n. So we take note that the error now is simply the difference between our true value or exact value and our approximate value, which is now taken by the equation E1 is equal to y1 minus the function of x sub 1. And since we know that the function of x is equal to ax plus b, then we could denote that e sub 1 is equal to y sub 1 minus ax1 plus b. Same for x2, the difference between y2 and the function of x2 is denoted by our epsilon sub 2 or the error. And again, we could expand this as e sub 2 is equal to y sub 2 minus a x sub 2 plus b. So take note that for our errors, we assume that the sum of all the errors in our data should be equal to 0. The application of the group averages method for linear equations can be derived using the following. So for a certain set of data, we can write its coordinates or we can list the coordinates in terms of x sub 1, y sub 1, x sub 2, y sub 2 until x sub n, y sub n. And for all of the coordinates, we could divide it into 2, wherein we take now half of the coordinates. So for the first half of the coordinates, that will be from x sub 1, y sub 1 until x sub m, y sub m. And for the second half of the coordinates, that will now be x sub m plus 1, y sub m plus 1, until the last coordinate, x sub n plus y sub n. So take note that if the number of coordinates is odd, therefore, for the first group, we add 1 coordinate to our first group. So example, if we have 10 coordinates, then the first and second half will have both 5 coordinates each. And let's say we have 5 coordinates that we are going to apply averages method. Then the first half will have 3 coordinates and the second half will have 2 coordinates. So given now the first and the second half of our coordinates, for the first half, we could write that the summation of the errors from 1m is equal to the summation of y sub k minus ax sub k plus b from k equal to 1 until m, and that will now be equal to 0. So since e sub k or summation of e sub k is 0, we could simplify our equation as y sub k minus exk plus b, and the summation sign can be distributed to the two terms. So with that, we could equate now y sub k, or summation of y sub k, to the summation of ex sub k plus b. Again, the summation sign can be distributed to the terms of axk and b. So in this case, we could write down that the summation of y sub k from k equal to 1 up to m is equal to the summation of a x sub k from k equal to 1 to m plus the summation of b from k equal to 1 up to n. So for the second half, we also apply the similar process. So we write the summation of the errors sub k from k equal to m plus 1 up n is equal to the summation of y sub k minus the quantity a x sub k plus b from k equal to m plus 1 to n equal to 0. So since e sub k sum is equal to 0, we could again simplify it as the summation of y sub k minus the summation of ax sub k plus b equal to 0. So from here, we could equate them and distribute the sign or the summation sign to our terms, taking also a similar pattern to that of the first equation or the first half of our coordinates. So from these two equations, what we do next is to take out the constant from the sigma or from the summation sign. So we'll have now summation of y sub k equal to a times the summation of xk plus m times b. So we'll also have the same pattern for the second half of the coordinates. We'll have now summation of y sub k equal to a times the summation of x sub k plus n minus m times b. So next is to divide the equations by, or the first half by m. So we get now 1 over m times the summation of y sub k from 1 to m is equal to a times the summation of x sub k all over m plus b. And for the second half, we divide it by n minus m. So we'll arrive at 1 over n minus m times the summation of y sub k equal to a times the sum of x sub k all over n minus m plus b. So from here, we have now the first term, or the left side of the equation will represent now the equation for the average y of the first group, or the first half of the coordinates, and a times the summation of xk over m is the equation for the average of x. So same for the second half, or the second group of coordinates. The left side is the average of y, and the first term of the right side is the average of x. So this is generally our equation for our averages for the first and second half of the coordinates for our linear equation. So from here, we could now write a linear equation for the first group as average y sub 1 is equal to a times x sub 1, the average of x sub 1 plus b. Likewise, for the second half, we have average of y sub 2 is equal to a times x sub 2 average plus b. So for us to understand further the application of group averages method for linear equations, let's have some example. So for example 1, we have to find the best line that would fit the following data. So we're given variables x, y. So we first divide it into 2. So we have 10 coordinates. So we'll have basically 5 coordinates per group. So next, we add up the summation of x's for the first group. So that will now be equivalent to 1.5, and the summation of y is equal to 1.5379. So from there, we are able to solve now for bar x simply by dividing the summation of x divided by the number of coordinates. So 1.5 divided by 5 is 0.3. Same for bar y sub 1. That is now the sum of y divided by 5, which will give us 0.30758. And then we move on to the next group. So summation of the variables of the second half, we have 4 for x and 4.48514 for summation of y. So we have 5 coordinates, so we divide the values by 5. So average x2 bar is equal to 0.8, and average of y sub 2 is 0.89702. So from the values of our average x and y for each group, we can now write our equation for a line. So we have bar y sub 1 is equal to a x1 bar plus b. So substitute the value of x1 and y1 average. So we get now 0.30758 is equal to 0.3 a plus b. And then for the second group, we have now y sub 2 average is equal to a times x sub 2 average plus b, or that is now written as 0.89702 equal to 0.8 a plus b. So we have now two unknowns, two equations. So we can solve this by solving it simultaneously through elimination by subtraction. So we subtract now equation 1, equation 2. So we'll have b canceling out. So we can now solve for A, which is equal to 1.17888. So from here, we can now solve for B by substituting the value of A in equation 1 or in equation 2. Either way will arrive at the same value of B, which is equal to negative 0.0460. So therefore, the equation now that would best fit the data given will be written as the function of x is equal to 1.1788 a minus 0.0460. So this is the answer that we want to get through curve fitting. So to check now for the function of x, which is equal to 0.70, so just substituting now 0.7 to x, we now arrive at f of 0.70 will be equal to 0.779136. And comparing this to the given data for x, y, which is 0.7586, so we can compute for the error of our line as approximately equal to 0.020536, which is almost minimal or almost equal to 0, so this could be acceptable. So to have now a graphical representation of our solution, for example number 1, so we were given x and y. So this is our plot for the given values, and for our best line fitting, the best curve that would fit the relationship between x and y, so it will now be given by our solved equation, and these are the values of y. So the green line now would represent the approximate line or the best line that would define the given x and y. So as you can see, there are small discrepancies in our graph. Okay. So another example for linear equation by averages method. So we determine the best line that would fit the following data. So in here, we are given variables x and y with 1, 2, 3, 4, 5, 6, 7 coordinates. So we divide this into 2 groups, and our grouping will be 3 by or 4 by 3. So for the first group, we now solve for their summation of x equal to 7.5. Summation of y is equal to 8.85. For the second group, summation of x is 12.5, and summation of y is equal to 13.75. And then next, we now solve for their average value. So for x, for the first group, that will now be 7.5 divided by 4, giving us 1.875. And for y, average for sub 1, that is now 8.85 divided by 4, which is equal to 2.2125. And then for group 2, we have now 12.5 divided by 3. That's equal to 4.1667. And bar y for group 2 is 13.75 divided by 3, which is 4.5833. So using now our average values, we now apply it in our linear equation. So for group 1, we'll have 2.2125 equal to 1.875a plus b. And then for group 2, we'll have 4.5833 equal to 4.1667a plus b. So solving simultaneously equation 1 and equation 2 by elimination through subtraction. So we'll eliminate b. by canceling it out. So we arrive now at a value of a which is equal to 1.0.345. So substitute now using the computed value of a in equation 1 or equation 2. Either way, it will give us a value of b equal to 0.272. So in that case, we can now find the best equation that would give us the best line defining variables x and y as f of x is equal to 1.0345e plus 0.272e. So this is the final answer. So if you want to take a look at how should the variables will look like in graph, then we have now our given variables. So it's almost a straight line, but the best line that will define it will be using this equation. So given x, we solve now for the function of x. So we have 1 with 1.373, then 1.5, 2, 3, 4, 3.5, 4, and 5. So using now these values, we'll now be able to see what our line should be. Another application of the group averages method is for quadratic equation. So the following is the procedure in determining the best fit curve for quadratic equations. So the first step is to transform the equation of the curve into the general equation of a line. And we do that by providing a point along the curve and identifying new values for x and y. So from here, we determine the coefficients for the general equation, a and b. And from there, we could now proceed with the best line method of group averages method. So to understand the application of the group averages method to quadratic equation, let's have another example. So given now the equation of a curve, which is y equal to ax squared plus bx plus c, we determine the best curve that would fit the following data. So we're given 10 coordinates for variables x and y. So what we do first is to create an equation of the curve using any point from the table. So in this case, I'll be using 0.2 and 0.2013. So in this case, we'll have now y equal to ax squared plus bx plus c as our equation 1. And applying the points selected, we have equation 2. So we'll have now 0.2013 equal to a times 0.2 squared plus b times 0.02 plus c as our equation 2. So we have now two equations. So we take the difference of equation 1 and equation 2. So we'll have y minus 0.203 equal to a times x squared minus 0.2 squared plus b times x minus 0.02. C and c for equation 1 and 2 cancels out. So if we're going to simplify x squared minus 0.2 squared, we could simplify this as x plus 0.2 times x minus 0.2. So if we're going to look at the second equation, we have similar terms for a and b. Thus, we could bring this term out. So we arrive at y minus 0.2013 equal to x minus 0.2 times the quantity a times x plus 0.2 plus b. So simplifying further, we have y minus 0.2013 all over x minus 0.2 is equal to a times x plus 0.2 plus b. So if we observe the format of this equation, this is now similar to the equation of a line, which is y equal to ax plus b. So take note that this term is representing now y in our linear equation, and x plus 0.2 represents x in the equation of the line. So from there, we divide our given coordinates or our given points into two. So we have now our first half and our second half of the given points. So for the first half, x is x plus 0.2, and the new term y is equal to y minus 0.2013 over x minus 0.2. So just substitute these values of x and y in our equation. So we'll arrive at 0.3, 0.4, 0.5, 0.6, and 0.7. For y, we have 1.011, 0, 1.032, and 1.0475, and 1.066. And then we move on to our total for the new x and the new y. So we have 2.5 and 4.1565. So we have a total of 5 coordinates for our first coordinates or our first half. So we'll be able to solve for the average. So we have 0.5 and 0.8313. So next group, we have now 0.6 until 1. So the new value of x now, using this equation, we have 0.8, 0.9, 1.0, 1.1, and 1.2. And the new value of y will be 1.0885, 1.1146, 1.1447, 1.1789, and 1.2174. So from here, we'll be able to get now the total value of x and y as 5 and 5.7441, and their average for the second group as 1 and 1.1488. So from our computed average value of the first and second group, we can now write our linear equation as for the first group, we have 0.8313 equal to 0.5a plus b, which will be our equation 3. And for the second half, we have 1.1488 equal to a plus b, which is now equation 4. So we have two equations, two unknown. So we simplify this by elimination through subtraction. So we'll now have negative 0.3175 equal to negative 0.5a, giving us the value of a equal to 0.635. So substituting the value of a in equation 3 or 4, we arrive at the value of b equal to 0.513. So from the computed values of a and b, 0.635 and 0.5138 respectively, we can now substitute this to our second equation, which is 0.2013 equal to a, 0.2 squared plus b times 0.2 plus c, in order for us to solve the constant value c. So from here, we'll be able to get now c is equal to 0.07354. So with a, b, and c already known, so the best curve or the equation that would best describe the relationship of x and y is f of x, or the function of x, is equal to 0.635x squared plus 0.5138x plus 0.07354. So another example for the application of group averages method for quadratic equation. So we define or determine the best curve of the equation y equal to ax squared plus bx plus c to fit the given data. So again, using any point from the given table or the given points, we create an equation of the curve. So we use now points 2, 3.3. So we'll have equation y is the general equation of the curve. And equation 2 will be the equation of the curve using the chosen point. So from equation 1 and equation 2, we take their difference. So we have now y minus 3.3 equal to a x squared minus 2 squared plus b times x minus 2. So again, if you're going to observe, this equation will be further simplified as x plus 2 times x minus 2. So again, we have similar term for a and b. So we have now y minus 3.3 equal to x minus 2 times a times the quantity x plus 2 plus b. So again, we have a simplified form of the equation. Y minus 3.3 over x minus 2 equal to a times x plus 2 plus b will be a representation of our linear equation y equal to ax plus b, wherein y now is equal to y minus 3.3 over x minus 2, and x is equal to x plus 2. So from there, we divide our given variables or given points into two sections. So we have 3:2 as our division. So for the first half, we'll have now the new variable x is equal to x plus 2. So we have 2, 3, and 4. And the y for the first group is 1.15, 1.5, and 0. So from here, we get your total value of x and y. So 9, 2.65. And our average, so we divide the total by 3. So we have 3 and 0.83 for x and y respectively. For the second group, we have same equation. We just use the values of the second group, which is 3 plus 2, so that's 5, and 6. For y, we have now 1.2 and 1.5. So for our total, that's 11 and 2.7, giving us an average of x and y of 5.5 and 1.35. So from our average values, we can now take our linear equation, equivalent linear equation of the given points as a equal or y equal to ax1 plus b, which is 0.883 equal to 3a plus b, which represents equation 3. And from the second group, we have now equation 4, which is 1.35 equal to 5.5a plus b. So we have two unknowns, two equations. So we can get now the difference of equation 3 and equation 4, which will give us a value of a equal to 0.1868. So from there, we substitute a in either equation 3 or 4, which will give us a value of b equal to 0.3226. So substitute a and b in equation 2. So we get now 3.3 is equal to 0.1868 times 2 squared plus 0.3226 times 2 plus c, giving us now a value of c equal to 1.9076. So with the variables a, b, and c computed, we can now write the equation that would best define the curve y equal to ax squared plus bx plus c with the given data. And that is now f of x is equal to 0.1868x squared plus 0.3226x plus 1.9076. Another application of the group averages method is for the exponential equation. So, the procedure now in determining the best fit curve for exponential equations would be to transform the equation of the curve into the general equation of a line. So to do that, we use the log or the logarithm to draw the exponent x down to the equation with variable e or constant a. Then we determine the modified equation for y. And from there, we proceed with the best line method using group averages method. So for example 1, using group averages method, we determine the best curve that would fit the data of the equation y equivalent to a raised to x times b. So in here, we simplify y equal to ax times b, or a raised to x multiplied to b using logarithm. So we'll have logarithm of y is equal to the logarithm of a raised to x times b. So from your algebra, we simplify the logarithm of products as the logarithm of a raised to x plus log of b. And again, we could simplify a raised to x as x log of a. So from here, this equation now would be representing the equivalent equation of the exponential equation to a line with log y as the equation we use to determine the new y or modified y. And then we have log of a as the equation to determine variable a or constant a. And log of b is the equation that would represent constant b. So from there, we again divide our given points into two. So we have the first half, we have 0.1 to 0.5. So we determine the new value of y, which is equal to the log of the given y's, and that is equal to negative 0.999132, negative 0.696156, negative 0.516413, negative 0.38637, and negative 283079. So from here, we'll be able to get the sum of our values. So we have 1.5 and its average 0.3. The sum of the modified y is negative 2.88115 and its average is negative 0.57623. So next, we move to the second group or second half of the given data. So we use still the same equation. Modified y is equal to the log of y. So we get negative 0.19665, negative 0.119987, negative 0.051538, 0.011359, and 0.070112. So for x and the modified y, we get now their total or their sum and their average as 4 and 0.8 for x and negative 2 or 0.286119 and negative 0.057224 for the modified y. So from there, we can now write our equivalent equation for the line. So for the first half, we have negative 0.5623 is equal to 0.3a plus b. And for the second half, we have negative 0.057224 equal to 0.8a plus b. So from our equation for the first half, we have here equation 1. And then from the second half, we have equation 2. So we eliminate b by subtraction. So we arrive at negative 0.519006 equal to negative 0.5a, giving us the value of a, which is 1.038012. So substituting a in either equation 1 or equation 2, we arrive at the value of b equal to negative 0.887633. So from here, we now substitute the computed constant values in the equation or the exponential equation y equal to a raised to xb, as the function of x or y is equal now to 1.038012 raised to x multiplied to negative 0.887633. So another example for the exponential equation or application of group averages method. So for the given data, we determine the best curve that would fit the data for the equation y equal to exb. So again, same as the first problem, we have a simplified equation of the exponential equation as log of y equal to x times the log of a plus log of b, which would be representative of the equation of a line. So from here, we divide now our given points into two. So for the first half, we'll have the first three variables with modified y equal to log of y, which will give us 0.07918, 0.36173, and 0.54407. So from here, the total of the x is 3 with average 1, and the total of the modified y is 0.98498, and its average is 0.32833. And then for the second half, composed of 3 and 4, we compute for the modified y, which is now equal to 0.68124 and 0.70757. So we take the sum of x is 7, its average is 3.5. The sum of the modified y is 1.38881, and its average is 0.694405. So from here, we get now the linear equation or equivalent linear equation of the first group or first half as 0.32833 equal to 1a plus b, and the equivalent linear equation for the second half, which is 0.694405 equal to 3.5a plus b. So to eliminate b, we subtract equation of the first group and the equation of the second group. So we'll arrive at a value of e equal to 0.14643. Substituting a in either of the two equations, we get a value of b equal to 0.1819. So using now the equation a and b, we get the equation of the function of x, which is equal to y, is now equal to 0.14643 raised to x times b, which is 0.18190. So that's it for the first method of curve fitting, which is the method of group averages. Thank you for listening.